As we talked about in class, the amount of money in an account at the end of T years, if the money is continuously compounded, is A equals P times E to the RT. So we're going to keep that in mind, and as I may have said already, my way of remembering this formula is there's this shampoo called PERT shampoo, and if you use PERT, P-E-R-T shampoo, then your hair continuously smells good. And so feel free to use that way of remembering that, but PERT, usually pretty easy to remember. But remember, we are only allowed to use this formula when the interest in our account is being compounded continuously, and there's the other formula that you already learned when the interest is compounded n times per year. So that's another lesson, but for today we're going to be talking about only interest that's being compounded continuously. So let's talk about this first example. Suppose you invest $2,000, and that's our initial investment, that's the P, at an annual interest rate of 5.5%. Now that's an R, so the interest rate is 5%, but we always want to make sure we multiply, or we write that percentage as a decimal. And remember, when you change decimal or percent to decimal, you have to move the decimal over 2 places to the left. So we get R is equal to 0.055, and then it says how much will you have in the account in 10 years, and that's the T. So let's write that down right down here. I always make a point of writing down exactly what my variables represent. And so P is equal to 2,000. We have the R is equal to 0.055, and the T value, again, that's the 10 years. We're going to leave the money in the account for 10 years. We're going to see how much we get. So the formula, again, the A equals P, which is 2,000. E is a constant. Raise that to the 0.055 times 10, and we should get a value that 5.5% per year for 10 years. It should be a good amount of money in the account. And so let's use our calculators for this part. All you have to do is type it in, 2,000, and you multiply that by E, second E, raising that to the 0.055 times 10, and then you just hit enter. And you can see your $2,000 has grown to almost $3,500, so 3466.51 will round to the nearest penny. 3466, so $3,466.51. So that's how much money will be in your account at the end of 10 years, given the initial conditions. All right, let's try another one. You might want to pause the video and see if you can do this next one on your own. So example 2, suppose you invest $7,500. Now that, again, that's our initial investment, that's the P value. 7% as a decimal is 0.07, and it's compounded continuously. So part A is how much will be in the account at the end of 10 years. Well, that's the T value of 10. So again, P is 7,500. The R is 0.07, and the T is equal to 10. And so the amount in the account, given an initial investment of 7,500, an interest rate of 7% for 10 years, typing that into the calculator, we just get 7,500, multiply that by E to the 0.07 times 10. There's no need to simplify, even though you can do 0.07 times 10 in your head, perhaps. No need to simplify that, just go ahead and plug it in. So at the end of 10 years, that 7,500 has become more than doubled. So $15,103.15. So we're going to write that down. So $15,103.15. So a 7% interest rate is as you can see, just in 10 years, your money's doubled, more than doubled. So that's outstanding. Now, let's look at part B. So part B, we already have part A checked off. Part B, how long will it take for the account to reach $20,000? Well, this means, let's put our variables in here, for the account to reach $20,000, that's the A value. That's the amount in the account after a certain number of years. So $20,000 is your A. We started again with our 7,500. That's the P value. The T is the value that we don't know. That's what we're trying to find. We're not really sure what the T value is. And then the R value, again, is still 0.07. So the way we set this up is, let's do this over here. We use our equation A, which is 20,000 in this case, equals P, which is 7,500, times e to the R, which is 0.07, times T. And again, now you can see that the T value, or the value we're trying to figure out, that's in the variable, and we haven't gone over the lesson on how to actually solve this yet, so we're going to just use our calculators to go ahead and solve this. So I'll leave that there, and if you remember how we solve any equation, we go ahead and let the left side equal our y1 and the right side equal our y2. So if we are able to use our calculators to solve equations, we can easily just do that same thing that we've always done. So pause the video, and enter these values into your calculator. And I'm going to go ahead and keep going here. We're going to adjust the window. Now, one thing actually I should mention. Notice that in this equation here we have a T value. Well, you don't have a T independent variable on your calculator in function mode, so I want you to notice here that there's an X in place of the T, so we need to understand that on the calculator, whatever we get for X, that's our value for T. So X on the calculator represents T, time, in years in the problem that we're working on. So the window, we want to adjust the window. Make sure you adjust yours the way you see it on my calculator. Since the X value on the calculator represents time, time can't be negative, so we're going to start the X min, the domain for the X. The X min is 0. The X max, we're just going to go up to 25 years. We'll see, just get a good window there for the time. It's okay to estimate a little high on the time, but then now we have to estimate, well, what's our Y min? Well, the Y min, you can see here that we need the Y's to go ahead and be high enough to see that 20,000, and so let your Y min be 0. Now Y is going to definitely be a positive number, so we'll let Y min equal 0, and then a Y max equal 25,000, so that we can see the 20,000, and then adjust your X res to 3, and then go ahead and hit graph. And when you hit graph, let me adjust my window here to 26, just so you can see it graphed. The first graph is the Y equals 20,000. The second graph is our exponential function, that rate at which the amount of money in our account is growing. And where they meet is when the left side equals the right side. So in other words, when the red graph hits the blue graph, the red graph's value is $20,000. And so we want to do second calculate, intersect, so we can scroll down to number 5 and hit enter, and we can see the cursor is blinking on Y1, and you hit enter, the cursor is now blinking on Y2, hit enter, and then guess, just leave the cursor there, and it shows us that here X in this case, but in the problem it's T, it takes a little over 14 years, 14.012 years. That's not a dollar amount. Again, the T value is in years. And so it takes about a little over 14 years for the money initially deposited as $7,500 to reach a value of $20,000. That's not very much time. So if you can get a 7% interest rate on your money, that's really, really good, and your money can grow pretty quickly. So I'm going to stop this video, and in the next video we'll work on these graphs.